So ladies and gentlemen, please join me in welcoming to our event, David Thirtyacre. David.
So just to get started here, if I don't skip too many slides here, we'll jump into the RSO. We'll talk about a little bit about what it's about and where it comes from, and then why Embry Riddle is interested in doing RSO, which is probably a big question. We'll get into live streaming a little bit because I think there's some confusion between live streaming and remote split ops and what the differences are there. We'll go through the different software setups that we are using at the worldwide campus. And then, of course, there's a lot of challenges that are associated with this, as you can imagine, particularly failures of different systems and things like that and how you cope with those issues. And then somebody brought it up previously there about the FAA and the BLOS waiver. Matter of fact, as we speak, there's a meeting going on back in DC between the FAA and some folks that are lobbying for us to get this approved. So there's a possibility, but before the end of this, that we might have word that it's approved or not. So we'll get into that, and I'll kind of talk about that trail and where we've gone with that. So just jumping into it here as far as RSO, most people are familiar with this as far as how the military operates their unmanned systems. This really became mainstream in about the early 90s with some of the operations in Bosnia, Herzegovina, and that type of thing. But the idea here, as you can see from the definition of the joint publication there for the military, is that there's geographical separation between this mission control element over here that's actually with the GCS and the launch and recovery element over here. There's lots of reasons to do this. Amongst them, the footprint, for example, that you can have. Instead of having this whole part over here, you can now distribute that, so you have a smaller footprint forward. And also the speed of the aircraft is significant because you really don't want to be a long way away from your area of responsibility, because at 60 to 90 knots, it takes a while to get to wherever you're going. So being as close as possible really helps out. One of the lightning bolts, as you'll see throughout this my presentation here, are important because this kind of shows the way that the communication is working, and this is similar to how we are going to use our remote split operations, where we have the who's controlling the aircraft separated from the actual launching area. So in this case right here, what you have is the launch and recovery element does the maintenance. They take the aircraft off and they use a line of sight type of data link, a C-band data link with very low latency. So it makes the standard operations around the airfield much easier. They take the aircraft up. Once they establish communications through whatever the architecture might be, they go ahead and then transfer control over to the ops center over here, or the mission control element. And that mission control element then carries out the mission for the next several hours, if not days, with the aircraft. And when it's time to come back and land, that aircraft will then come back into the range of the line of sight data link over here. They'll take control of the aircraft, bring it back, and land it over there. And as these lightning bolts I was mentioning are going through here, there's several pieces of data that's transmitted here. Everybody always thinks of the full motion video, but there's also a command and control link that has to come from the GCS over through the network and down to the aircraft. For example, turn left, and then the aircraft responds with telemetry, sending that information back as well. And on that signal as well is now your video, which is going to be dispersed to users out there that might need that information. So that's basically how remote split ops is set up and how we're going to define that for what we're going to talk about here today. So why in the world is Embry Riddle interested in this? Probably the question that you're asking. So this is a depiction of our current flight activity, and as you can see, we're all over the country, and all these are students that are in different places. And by the way, we are still currently running our flight training class. Since we do everything online and asynchronous, the students still go out, they use a simulator, and they also do active flight, generally in their backyard. So we are still doing carrying on flight operations. Matter of fact, in the last 30 days, we've had almost 500 operations that have been conducted. So this gives you an idea of where we're at around the country. But the problem is that I might have a matrice up here with some really neat sensors on it and things like that I have up here in the Pacific Northwest. But the problem is that my student is down here in Florida. And in the courses, they generally just have a small aircraft like a Mavic or a Bebop or something like that. They generally don't go through the class already having a $30,000 Matrice with an X30 on it and a nice XT camera as well. So we really want to get our students to have experience using those sensors and everything else. And that's generally the reason why we're doing it this way, is the aircraft isn't available at the home station. And it allows them to collect data from advanced sensors and really use kind of the latest state-of-the-art type of software and systems that make them more attractive to employers out there. Another important part is that it also gives them experience in remote split operations and teleoperations. So they have that experience, how to go through the procedures, how to troubleshoot, how to fix the problems, and the communication that goes along with that. So we use that for the students so they can have that, again, to help them as far as the business goes. So if you look at how it's set up here, basically we have our remote pilot and command up here with the aircraft co-located there. They are going to have a direct link, just like always, to the aircraft through the local handheld GCS. And then that information is sent over to the, as the FAA calls it, the person manipulating the flight controls in another location. And at some point in time, we hand the aircraft over to that other person to execute certain tasks. Now, as I mentioned before, right now we are not actually handing it over to the student because we don't have our BLOS waiver yet, and the student is actually articulating what they would like us to do, and we do it on our end, and I'll show you some more of that here in a minute.
David,
but that's why we're interested in RSO.
David, may I pause to ask you a question there?
Yeah, you bet.
That is, as we know, the under Part 107, the remote pilot and command may allow another person to, as in the phrase you just used, manipulate the controls of the aircraft. If the remote pilot and command remains the remote pilot and command, it presumably has override authority for the person flying remotely, for the person manipulating the controls. Why do we need a BVLOS waiver?
Well, that's a great question. And the reason is because the way Part 107.31, I think, is written. And it says in there, it specifically says that the RPIC and the person manipulating the flight controls must maintain visual line of sight with the aircraft. Because of that one sentence, we're required to turn in a request a waiver and get that from the FAA. Which, just like you said, Patrick, and we'll jump into this a little bit more here, but it's a little hard to understand why it's required when the RPIC and the VO, which we execute here, are actually still within visual line of sight of the aircraft. That's a great question, and we'll jump into that here a little bit more in just a second. So I wanted to just take a little segue here and talk a little bit about streaming versus RSO and kind of go through a few of these capabilities, because we use all these different capabilities in our academics and throughout our classes, but it's important to understand the differences between some of these. So for example, screen mirroring is something that's used quite a bit. I use that very often. I like to use the Maverio BT300s or the 35Es that are the augmented reality glasses with the aircraft. So now I can look at the aircraft and I have the display right there. Well, it works great with the DJI products because it's incorporated into the Maverios, but with other aircraft, I can't do that. But there's a capability with the iPad that allows me to mirror that onto my glasses. So that's an example of just mirroring. I'm sharing what that looks like. Screencasting, something that we're familiar with Chromecast and something like that. It's what you have to have a common network, and then that you're able to talk back and forth with those. And matter of fact, I'll show you how we use that when we use the UGCS software that we use to make this happen. And then you get into the media streaming, and that's generally broadcast through the internet, and that's that bottom picture of a cell phone tower inspection there that they are using with an engineer back at his desk and the pilot out there flying her aircraft. And as she's flying around that, the engineer is giving her direction. Okay, look at this, zoom in over here, let me see that, take a picture from this area. So they can do live type of inspections. Above that is the Skywards Live program that they have that's part of their enterprise selection there, their plan. And that gives you telemetry of the aircraft that are flying around here. And by just clicking on an aircraft, you can start to see the parameters that are out there. The difference here, though, is that this right here, the telemetry, is generally less than about a second of latency. Matter of fact, the test that we've done using the Skyward Live here shows it about a half a second worth of latency. And that doesn't matter where the person's flying. We had some flying in Texas and Florida the other day and saw that same latency. However, when you're looking at something like this, when you're talking about pushing 4K video, the latency can be anywhere between about 2 out to about 25 seconds. So there are definitely considerations on bandwidth when you go into this. And that's that real difference between the live telemetry and the media streaming and the command and control signals. When you get into that full motion video streaming, that's where you start to take a lot of bandwidth. Matter of fact, streaming 4K at 60 frames a second is going to take you somewhere around 40 megabits a second in order to transmit that, which is one of the reasons we're really excited about 5G coming on, so we can stream some more of this. Now, RSO, as you can imagine, like I mentioned earlier, uses the command and control, the live telemetry, as well as the FM, the full motion video for the system. So we're using all of those. And if you look at the different live stream techniques out there, there's several different ways to do that. In general, what we use when we're flying DJI products is a company that's called Unleash Live, where we're actually able to go into the DJI Go4 app and then put in a custom URL, which you see down here, which now streams that out, and I can send a link to anybody and you can watch it, literally watch whatever flying we're doing if you have that public link in order to watch. So the live streaming thing is something that's really exciting. We use it a lot, but it's not the complete part of remote split ops. There's lots of other apps out there. There's some really neat things going on right now with AI, and this is an example from Unleash Live and their AI out there. This is looking at houses and how much of them are destroyed and things like that. They also have it for counting crowds. They have it for several other applications that are out there that they're working on. This next picture is from mainly a law enforcement program that's called a 1021 flight, and they have very low latency on this, generally less than 2 seconds for what they're doing there. And then, like we talked about, we have the other streaming techniques that are used out there with some of the other ones there. So lots going on the streaming side. So bringing us back to RSO. So how the heck are we doing this? So we use a couple different pieces of software. In general, this is all based around the UGCS client software. And we also have that on our mobile device. So instead of using the DJI Go4 app, we use the UGCS for DJI on the ground control station. And then that's hooked up to a laptop using the UGCS client on there. And then we have a desktop sharing program that we call Eagle Vision, but it's really just Adobe Connect. You can also do it on Zoom now, but we still use Adobe Connect just for the security side of that. And again, the note there for the FAA is that we are not currently doing this. We're not giving control over to the students because we don't have the waiver yet. But hopefully this will make a little more sense now about how we're putting this whole thing together. So if you look at the right side of this, when we have the aircraft and we have the GCS down here, we do this part of it every day. That's the standard operations that we're doing with unmanned systems. The only difference is we're not using DJI Go4. We're now using UGCS for DJI. And then the other part of this piece, all of this side of it over here, is something we do every day as well at the Worldwide Campus, where we have an instructor using a laptop through some sort of a router or a hotspot over to the student. And a lot of times we have the students using hotspots as well, depending on where they are located. So we are able to give the student control of our computer for several different reasons, for doing presentations and things like that, but also for doing things like using a remotely operated wind tunnel and things like that. We can give them the control of the computer. So we do that part already, and we do this part. So the only real difference here is we are now hooking up the GCS software to the client software through a hotspot or through a wireless network, which is common between the two of them. And that's that casting part I was talking about earlier, where we have two programs on the same network, and now they are able to pass information back to each other. So the client software and the GCS software are connected through the hotspot, which is also then sent over to the student. So all these connections we've done several experiments with them all, and as you start losing different pieces of it, for example, this goes away, the only difference is the student isn't going to be able to view the control. If you lose something over here in this area, that just means that this is the primary control to the aircraft, and now this is cut out. So we've done all sorts of testing on this, and 100% of the time, the RPIC, no matter what happened in the system, was able to regain control of the aircraft with the GCS and land it. It's literally the flip of a switch, if you will. So if you're familiar with DJI, if you're in the P mode, that's what makes this whole thing happen. As soon as you exit the P mode to any other mode, then the actual GCS here, the handheld GCS, is the only thing tied to the aircraft at that point. And that's how you take control back of it, is literally the flip of one switch. And that's where we're at with the FAA, is trying to convince them that that one switch flip works. And we've been at that now for the last basically 2 years, trying to convince them with 3 rejections so far, trying to convince them that that switch is required. So that gives you an idea of the overall architecture on how we have this this system set up. Now I'm going to get into the software a little bit. Patrick, were there any questions that came up so far with this?
No, it's been remarkably quiet out there, but thanks for giving me a break. And I'll remind everybody that you can use the Q&A tab at the bottom of your screen if you want to submit a question for David to answer regarding this project. So please feel free to chime in doing that. Otherwise, we're moving right along. So
all right, sounds good. Give me a chance to get a drink there.
Yeah.
So let's dive into the software a little bit about what we use here. So some of you may be familiar with UGCS, some of you may not, but it's a very robust program that we've used with them, and we are. I don't think we're officially partners, but we're definitely working closely together with them, and they've really helped us out in a lot of areas. So shout out to them for what they've done with this. But the UGCS software gives us a lot of capability, especially with now the client and the UGCS for DJI side of it. And these are just some examples of the flight planning that you can do. For those of you who have used Pix4D, we use that a lot in our program. But the Pix4D capture only allows you to fly basically at a set altitude above your launch altitude. It doesn't allow a map of the Earth, if you will, look at it, or to fly to set 300 feet AGL and have it fly that throughout it. And UGCS allows us to do that in the planning software. It also has some other unique features, for example, being able to map vertical structures. And this is very important for things like dams, especially up here in the Pacific Northwest, being able to map these areas and put together a photogrammetry program using that type of mapping. And then another one that we use for our students as well is the search and rescue. UGCS builds a search pattern based on the altitude, the speed, and the camera and sensor combination that you have, and it's able to build these very quickly, so you can get out to an area and do a search knowing that you're not missing any area out there. So that's just an example of the flight planning side of it. And then as we dive into the actual,
could I get you to go to the previous slide? And this is just a question I personally have, because I haven't had much experience with UGCS yet. When you're taking the image on the left there, when you're planning a mission on a mountainside, how do you get the terrain elevation data that you need in order to create that terrain following flight path for the aircraft?
That's all located in the map package that's used there. So with the DTED data, the digital terrain elevation data, get DTED data, and some of it depends on the actual resolution of that. A lot of times you get DTED that's generally about every 5 meters, which is generally fine, but you can actually get it down to under a meter. So every spot even under a meter you can have an altitude for. So that is all incorporated into the map package that comes in there.
Impressive.
So the flight plan, like I said, can be all done right here, and then getting into the execution side of it. This is the actual execution when we're flying that. You can see there's the video down here of the aircraft, which is showing this is actually a capture mission here. So it's taken stills, but it's still showing what the aircraft is seeing down here. You can see a depiction of the flight plan that was built. Again, the 3D model. You can see the where it's at. This is level here, obviously, so it doesn't quite show the altitude capability, but it gives you a 3D depiction of that, so it's very easy to QC your patterns. You have the telemetry, like I talked about, that's coming back, that's telling you what the aircraft is doing and what it's up to. This RC link being extremely important right over there. And then these are the commands down here. So what the student can do is they can plan this whole mission. They can then go to the laptop of the instructor who's co-located with the aircraft. They can upload the mission to the system. And then at that point in time, once they've QC'd and everything's ready to go, then they go ahead and verbalize for the RPIC to go ahead and take off and start the automatic mission through there. So the student isn't actually clicking these because, again, we don't have, I was going to say that's going to go to the next slide if I click that. That's funny. Come on. Go back.
Technology's wonderful when it works, isn't it?
There we go. Now it's going to go back one more probably because I did that twice. Anyway, so the student then will tell us to push the button. There's also capability to do a joystick mode down here where you can actually fly the aircraft manually. And as soon as we get our waiver, we're going to start doing that. And now it's going to be the capability for the student to actually manipulate the controls on the aircraft. Keep in mind, though, there is some latency involved with these pieces here. So anyway, what I wanted to show, though, was that is the controls to give the commands to the aircraft. It's basically all automated, and the majority of the work here is done in the mission planning side of it. All right, now we'll get to the next one. So what are the problems with RSO? Latency is a huge issue. You have latency issues, as you can see in the slide there, the standard wheel that you'll see spinning around, which makes life rough, especially when you're doing an inspection, and you really don't want to have that type of thing in here. The resolution and the frame rate play together for the amount of bandwidth that you need, and like I mentioned, sometimes upwards of 40 megabits a second. A standard DJI controller is pushing somewhere around 10 to 12 megabits a second coming back from the video from the aircraft, just to give you an idea about what it takes to do that. Again, like I mentioned, 5G is hopefully going to solve some of these issues that we might have. But those two pictures over there are just examples of what happens when you have the resolution is dropped down, or you get bits that are not actually sent, and so you get a degradation of the picture. And especially for inspections, it's extremely difficult to still be able to do an inspection when you start losing resolution. So your frame rate and your resolution combined with the quality of the network that you have to be taken into consideration before you start doing any of this, because it's very easy to just push the 4K 60 frames a second go, when in reality you probably don't need much more than 1080p and maybe standard 27, 29, or 30 frames a second, even lower than that. Matter of fact, your IR sensors are generally only going to go across at about 9 to 10 frames a second. So there's a lot of consideration on the aircraft setup and the video setup on how to make this happen.
David,
network coverage.
If I may, David, let me jump in and ask you a question there, which is, have you given thought, and I'm guessing you have, and other people in the remote inspection business, to, say, watching the video downstream at 720p, which is a much more, manageable data rate, but capturing it at the field at 4K or whatever the inspector ultimately wants. So then once the inspection is, and I'm throwing up some air quotes here, done, the pilot then uploads the 4K video to the inspector, who then gets to view the flight in much more detail than they did in the field. The downside is the inspector cannot maybe see a small particle of rust on some fitting on your cell tower there, but on the plus side, they're able to work with the pilot remotely to much more quickly capture what needs to be done. Is that something which is being considered for this sort of work?
Yeah, absolutely, Patrick, and you hit the nail on the head. And that's typically how it is done. You're still going to record at whatever the end game user needs to have at that, and that's going to be different, as you know, if you're doing something for a movie, if you're doing something for an inspection, if you're doing something for a farmer's field, that's going to be different. But you're going to set those for what is the end game requirements the user has. So in most cases, you're going to use the highest quality that you can. In most cases, you're going to record internally with the aircraft, and then you're able to throttle the bandwidth requirements from there on, so you can get hopefully a good enough picture that they're able to accomplish what they want with your flight. And then, like you said, you always have the backup of those aircraft files. You can pull off that later. That's an excellent point. All right, getting back into this a little bit, abnormal procedures. Actually, the network coverage, by the way, is another big one, is making sure that you have enough coverage if you're going to do this. We find ourselves, especially up here in Washington, I'm out by the town of Eatonville on the foothills of Mount Rainier, and I've done some work for a land trust here where I've been way up in the middle of the woods, and there's no conductivity whatsoever in those areas. And obviously live streaming at that time becomes very expensive when you have to now do some sort of satellite type of hookup. So there are, however, my point here is there are capabilities out there to be able to use and still do live streaming, even though you're not in a cellular network coverage. But those tend to be, again, more expensive and out towards the commercial side, more than Embry Riddle can afford to do with those. There are some abnormal procedures, though. Security is a big question, which is, again, is one of the reasons why we use the systems that we do, because it requires a log on in order to get into the systems that we're using through Embry Riddle. And we actually have our cyber defense team that's at Embry Riddle that's working 24/7 that guards all of our networks, including the networks that we're using for this. And we also have down there, we have a separate server that is set up to run the UGCS client software down there. So there is some security to take into consideration. The control redundancy, I mentioned that earlier, in making sure that no matter what happens in the system, as long as the GCS, handheld GCS, still is talking to the aircraft, you're still good to go there. And then obviously there's other issues you have to be concerned with. And that brings us down to the visual line of sight 10731, which we've been trying to get the waiver for almost 2 years now. Again, I said this is our third attempt going through this. And the interesting thing is, all we're trying to do is waive the line of sight requirement for the person manipulating the flight controls. We're not trying to fly beyond line of sight out, 50 miles from anything, or from where we're flying the aircraft. At all times, the RPIC and the VO are visual with the aircraft and have a line of sight. That has not changed whatsoever. The only difference is that the person manipulating the flight controls is not co-located and can't see it. And as you can see from that bottom banner down there, the part that I have highlighted, the rejections that we get are basically because they're saying we can't detect and avoid a non-participating aircraft. And we kind of scratch our heads. We go, well, we can. The RPIC is standing there. They see a non-participating aircraft. They go from P mode to S mode and they land the aircraft. It's literally that fast. And so we've tried to rewrite this so the FAA would understand what we're trying to do. But we just haven't gotten there yet. And the other issue is, they said, how are you going to avoid operations over non-participating people? It's the same thing. If we have non-participating people show up, we push the button up to S mode and we move the aircraft so we don't fly over anybody that's not participating. So I'm not sure how the FAA is stuck on this one switch. That all we have to throw is that in order to regain the direct to control. But they've continued to send back obstacles. And one of those was, have you tested this? So we really went back and tested this from one end to the other. We went through hardware in the loop tests on the ground. We went through simulation, and we went through flight test. Of course, we had everything co-located when we did it. And 100% of the time, the RPIC was able to gain control of the aircraft within less than a second. Every single time, 165 trials with our field test, and it worked absolute every time. So anyway, we are again on our fourth attempt. We are hoping to get news soon. There's actually a sit down, like I said earlier today, up there with the FAA, and we are hopeful that they will understand a little bit more about what we're trying to do. But realize this package that goes up, this form right here, and all the information that goes along with it through the drone zone. This is it's several pages, 20 page type of documents, including all of the field flight tests and all that we're doing. So this is a massive package that's going up there, and it's just grown every time. So again, we fully support the FAA and what they're doing. We think they're trying to do things the right way. It's just a little frustrating trying to get some of this through up there to make it happen. So with that, if there's any questions, I'd love to answer those now. This is kind of the end of the RSO briefing before I jump into the next shameless plug for a class we have coming up. But Patrick, are there any questions that have come up there?
Well, mysteriously, David, we still don't have any questions, but I do want to assure you it's not just you and I talking to each other. We still have quite a few participants online. They just, apparently we're doing such a good job, and I give most of the credit to you, for explaining the stuff, and the questions I'm asking are sufficient to sort of slake their appetite for interaction. So
Well, I'll tell you what. Let me get to this next slide, and then I have a slide after that that'll hopefully that says questions on it. So maybe that will get some of those coming.
There's a burst of questions. So that's
We'll tell you what.
exciting.
Okay.
And all of them are from board members trying to goose this thing up. So that's
Well, let me get to my next slide real quick here. My shameless plug here. I heard STEM mentioned there earlier and everything. We have decided to reach out to teachers out there and administrators who are involved in STEM education, because we think that a UAS is the perfect tool to use for every single part of STEM, from physics experiments to coding to aerodynamics and everything in between. We really believe that using a UAS and bringing that into the classroom is a great way for the students to do hands-on training with it. So we are going to hold a free course. It's called a Massive Online Open Course, and a MOOC, and we are doing that starting on the 18th of May through the 31st of May for 2 weeks. Generally about 2 to 4 hours a week is what's required, but it's just a great chance for the teachers to get in there. The first week is basically how to stay out of trouble, all the rules and regulations that go along with it, and things about insurance and liability, and just things to keep the school districts out of trouble. And the second week will be specifically talking about how to bring STEM into, or how to bring aircraft into the STEM side of this. And I just want to thank our partners there at RoboFlight Academy out of in situ. We support them every summer, and they've been supporting us in this as well, so we can get some more STEM engagement out there. So with that, now I'm onto that slide. What do you got, Patrick?
all right. Well, the first question was actually directed more to us at AUVSI Cascade, and that was, is a recording of this session going to be available? And the answer to that is yes, absolutely. We will send out, that is AUVSI Cascade, will send out an email at some point after the conclusion of the session, letting people know how they can access that recording. So yes, this material will be available to you after the session ends.
And by the way, we have no problem if you want to use this material in classrooms. We just ask that you still keep the Embry Riddle logos on there so that they know where it came from.
One question is, do you build 3D models for inspections? And I assume this is like, for example, that cell tower you were inspecting. So is it just live video or maybe high resolution stills, or do you actually take the added step and build a three-dimensional model that the end user can manipulate?
Well, that's an interesting question, because one of the pieces that a lot of pilots out there forget is asking and finding out exactly what the customer wants, because it completely depends on what they're looking for, and then guiding them to some of the products that might be available. I spend a lot of my time, I have a company on the side called Skyview 3D, and I spend a lot of my time with a user out there, trying to get them to understand what the requirement is from the customer, what they really are looking for, and then schooling the customer on what is available is also a big part of it. But in the cell phone tower area, it's very interesting, because building a 3D model off of such a complex 3D maze of different things up there is extremely difficult for photogrammetry. Now, it can be done, but you typically have to do a lot of cleanup on the different items in there in order to build a 3D model of those cell towers. I'm not saying it's not done, and we have done it and we do it, but it can be very painstaking, and the parameters for which you take the pictures are very important on how you do that. But typically, you can pull a 3D map off of either using a photos, which is preferable for Pix4D, but with programs out there like HiveMapper, they strictly use the video to do it. So as long as you have the metadata going into the video, so it gives the lat longs and the altitudes and the camera pointing angle and that kind of thing, you can build a 3D model as well out of the video. So to answer the question directly, I think the answer is it depends on what we're doing. The majority of the time with the classes and the projects that we are doing, we are building 3D models. We might be building orthomosaics or things like that, but we use a Pix4D throughout all of our classes.
Yeah, and just to add a little resolution from my own recent experience on that question, David, I was working with Dr. Joseph Soretta, who's a colleague of ours at the Department of Flight, and he and I took the series of photographs of a cell tower in order to build a 3D model of it, and he actually processed it. And I have to say that that was, although I was using the point of interest tool and some other things to help me, it was nonetheless some sort of white knuckled flying, and a number of other drone pilots were there with me, and they were awfully glad that I was the one manipulating the controls, because it was not a piece of flying to be taken for granted. And then once that was done, and I uploaded these probably 300 some photographs for one cell tower to Joe, it took him 20 hours of cleanup in order to actually sort of extract the cell tower from the background. And Joe, for our audience to know, is an expert. I mean, an authoritative expert on this stuff. And so if it took him 20 hours, it would probably take somebody else 30 or 40 hours. And I'm certainly not an expert at understanding cell towers, but we were actually looking at some other properties of the cell tower, and I'm not sure that even with all that work, you'd be able to make out every single cable connector and all the other hardware that's up there. So yeah, making a 3D model of a cell tower is not a negligible, and it's not negligible at any step in the process. It's time consuming and challenging, et cetera, et cetera. So actually, we've got a great question here, which we probably should have, I being a good moderator, should have realized and asked you to define, but we're both DJI guys. What is the difference between P mode and S mode?
Oh, that's yeah. I should have discussed that there. With the DJI products, there's a P mode, which generally stands for program mode, which is the normal mode for the aircraft that'll be flying, and it's the GPS mode. It restricts your velocity to generally about 30 miles an hour, somewhere around there. But you need to be in that mode in order to have the ability to hook up to like UGCS. Or anything like that. That's the mode you need to be into. And then the S mode is the sport mode, and that basically cuts out all of the other automated flight features. So in order to do automated flight, you have to be in the P mode. Selecting the S mode takes you out of all the program modes and just goes back. So for example, even doing Pix-40 capture, if you're doing Pix-40 capture mission and something goes wrong, the emergency procedure that we advocate is as soon as the aircraft does something you're not expecting, you flip over to S mode, because that takes the Pix-40 capture and the waypoint navigation off the board, and now you're back to a manual control.
All right, thank you very much, David. And we have another question here, which is an interesting one, which points out that, if you're capturing 4K video or 20 megapixel stills and you're capturing a lot of them, that's you're accumulating a lot of data very quickly. Megabytes and gigabytes start adding up fast. And what our questioner wants to know is there a challenge in terms of the onboard handling of that data? I mean, can the aircraft itself become overwhelmed with the data its sensors are generating? Or is that not an issue? And then what is 5G going to do in terms of that bottleneck?
Okay, those are excellent questions. The good news is that the improvements in the video and the photo capture, the miniaturization of all that, which we're now, we have a Mavic 2 here Pro behind me that has a 21 megapixel camera on it, and they're getting bigger and bigger. The good news is that the storage size required for that is expanding as well. So, for example, in that Mavic 2 Pro and in the other aircraft that we have that have very good cameras on them, you can now buy a 128 gigabyte SD card that goes in those. So fortunately, the increase in the memory has basically followed the increase in the camera capabilities. So we generally don't run into a problem with that. The only time is if you have a camera that is retrofitted to an aircraft that might not have the storage to do that. But we generally don't have a problem with that. Matter of fact, a lot of things now are actually being, a lot of the AI or processing is actually done on the aircraft. An example for that with the Mavic 2 Pro is the ability to do time-lapse photography. That is all done on the aircraft and processed on the aircraft to make a video out of it. Now, getting to 5G, 5G, it was designed. There's a lot of the design is in there specifically for the operation of UAS in there, and the big things are the latency is decreased in it, and the bandwidth is through the roof. So the bandwidth is, I can't remember what the actual number was, but I think it's about 100 times the amount of bandwidth. So it's not uncommon for the 5G network out there right now, some that are deployed, to get a gigabyte a second of download speed. So when you're talking about a gigabyte a second, a lot of your concerns about bandwidth go away. Now, the problem is everybody in that network has to also have that type of bandwidth. But when you're talking about, bandwidth even up half a gigabyte a second, you're talking about, a huge increase in the amount of data that can be processed.
All righty. Another question here, and I sort of feel that we answered this, so maybe as you answer it again, we'll get some clarification. One question wants to know, what software is it that we use for this to accomplish these various tasks?
It's that the UGCS is the main company that runs it. So it's UGCS. They have the client software, which is the mission planning software. If you've been around for a while, it's kind of the old mission planner or the RG pilot, reconfigured and more complicated. So that's kind of what that is. And then we have on the actual app that is through the SDK for DJI is the UGCS for DJI, which is actually a different app. Just like you would use Pix4D capture on your iPad in order to do a Pix4D capture mission, you're not actually running DJI Go 4. Same thing with this. You're using UGCS for DJI as the actual app you're using on the GCS.
Got it. And then another question is, do we have automated change detection if we're re-inspecting the same asset? We fly a wall one month, we come back in a month, fly the same facade, and it's like, hey, look, there's a crack here that wasn't here before. So are we doing that? To what extent is that even possible with the technology? And the questioner points out that if you're flying the face of a dam once every 6 months, tedium could set in, but artificial intelligence is really good at not being put out by tedious stuff and at detecting small changes. So what's your take on that?
Well, that's a very up-to-date question. Matter of fact, I don't know if it was yesterday or the day before, we had a telecon with HiveMapper, and we've been using HiveMapper for a little while, taking a look at a change detection, that exact thing. So flying a video, we used it down at one of our courses we had for federal law enforcement, where we did change detection with that. We flew the aircraft over the area and then put it into HiveMapper, and it does change detection. And they have it's quite a powerful AI platform that they have, and we are hopeful that we're going to be able to get some licenses with them to be able to experiment more with it. But yes, absolutely. And inside some of the other programs I mentioned, Unleash Live with their AI that they have, for example, pothole detection right now. So you're able to find things like that through their AI, and then again, HiveMapper has the ability to do that change detection, which is where things are going to go, no doubt about it.
All right, and this last question, certainly somebody near and dear to our heart, and this is not a plant. I did not make up this question. This is a legitimate question from a legitimate audience member, is they want to know, can we provide them with a link to the MOOC?
Absolutely. Yeah, it's been a little bit frustrating over the last couple of days because, as you can imagine, our LMS is through Canvas. Our learning management system is through Canvas, and we've used that for a long time, and they're very responsive to us because we're one of the larger schools that uses their systems. Unfortunately, everybody's using them right now, and they still, as of this morning, have not supplied us a link to sign up yet. So yes, I will get that link out, but it's basically just a page that says, hey, this is what we're doing, and here it is, but it's missing that thing that says sign up or register, and we're waiting to get that out, but I will include that here as soon as we're done.
All right,
so you can have an idea what it is.
Well, I think I can speak for the entire AVSI Cascade board when I say, when you provide us with that link, we'll also be happy to share it, not only with the people who participated in this webinar, but with all the folks who are on our emailing list. So hopefully they can pass that along to teachers and other people who might benefit from the training we're going to be providing. So
absolutely.